In this video, we are discussing questions related to electricity for AS levels. And majority of the questions in this video are taken from the year 2013, October, November, variant 1-1. But there are some other questions as well on the same topic and for AS level. The first question is two lamps are connected in series to a 250-volt power supply. One lamp is rated 240 volt, 60 watt, and the other is rated 10 volt, 2.5 watt. Which statement most accurately describes what happens? A. Both lamps light as at less than their normal brightness. B. Both lamps light normally. C. Only the 60 watt lamp lights. D. The 10 volt lamp blows. When will a lamp blow? When it gets more power than its rated power. So we have to check whether they are going to get their rated power or not. So there are several methods of solving these questions. This question we can solve it in different way. First thing, well, we should just draw a rough diagram. This is the power supply and this is 250 volt. This is lamp A and lamp B. So this is 240 volt and this is 10 volt. So the total voltage is according to the voltage provided by the supply, because 240 plus 10 volt is 250 volt. And now let us check whether they get the required current or not, and whether the supply is able to provide the required power or not. So total power is this is 60 watt and this one is 2.5 watt. So let us check this power of the battery. In order to calculate the power of the battery, we need to know the current. Say this is bulb A and this is bulb B. Bulb A is 60 watt. So P is equal to VI. So I is equal to current through, in series circuit, current will be same through both of them. So I is equal to P over V. 60 divided by 240. This gives us 0.25 ampere. And bulb B, if we check bulb B, then this will be 2.5 over 10. So that 2 is 0.25. It means same current flows through both of them. Now, voltage, total voltage is equal to the total voltage provided by the supply. And since this is a series circuit, the current will be the same. It means the current through supply will also be 0.25 ampere. So what will be the power of the battery or power of the supply? P is equal to 250 into 0.25. So that is equal to 62.5 watt. Total power of the two bulb is also 62.5. 60 plus 2.5, 62.5 watts. So it means battery is also able to provide the same power. It means both lamps will light normally. And there is another way also. We first find out the resistance of the two lamps. And then we can find out R is equal to lamp A. P, we know the relationship. Power is equal to V square over R. So lamp A, the voltage is 240 square over R is not known to us, but its power is 60. So what is R equal to? If we make R subject, we get 960 ohm. In the same way, we can calculate the current of resistance of lamp B. R is equal to P V square over P. Lamp B, what is the power? The voltage 10. 10 square is 100. 100 divided by 2.5 gives us 40 ohm. So total R is 960 plus 40 is 1000 ohm. Let us check the current provided by the battery. So I is equal to V over R. Voltage of the supply is 250 and the total resistance in the circuit of the two lamps is 1000. So that gives us 0.25 ampere. So that means the battery is able to provide that current, and total voltage of the battery is equal to total voltage required by the two lamps. It means both lamps will light up normally. Now let us go to the next question. This is related to resistance of length of a wire. Heating element has resistance R. The wire breaks and it is replaced by another different wire. Data for the original wire and the replacement wire are shown in the table. So here, what is the resistance of the replacement wire? The original wire, length L and diameter D and resistivity rho. The replacement wire has the same length, but it is thicker. Its diameter is 2D, but as well as its resistivity is also more than the resistivity of the original wire. So let us check what will be the value of the replacement resistance of the replacement wire. We know the relationship R is equal to rho resistivity L over A, area of cross section. Length is same, means length will not be affecting the resistance here, but diameter and resistivity will do. So the resistivity of the second wire is 2 rho and its diameter is 2d. When diameter doubles, the area of cross section of the wire increases 4 times because area is pi d square over 4. So when we double the diameter, the area will increase 4 times because there is square on this d. Okay, doubling diameter will increase area 4 times. When area increases 4 times means R decreases 4 times. So due to diameter, the resistance is 4 times less. But resistivity is doubled and resistivity is directly proportional to R. So this is 2. So it means for the new wire, we can write 2 row. This is original wire, new wire, same length. And this is, you can take what? No, pi 2d square 2d square over 4. So this will be 2 row L over pi into 4d square by 4. So this 2 and this 2, they get cancelled. So what is left here? Rho L over 2 times pi d square over 4. So it means pi d square, rho L pi d square over 4 is R. So R by 2. This is R. So and this is 2 in the denominator. So resistance is R by 2. It means B will be the answer. This is question number 36 of the same year. In this circuit below, P is a potentiometer of total resistance 10 ohms and Q is a fixed resistor 10 ohms. It means the resistance of P can be varied by moving the sliding contact from X to Y. The battery has an electromotive force of 4 volt and the negligible internal resistance. Battery has no resistance and voltmeter has very high resistance. So the slider on the potentiometer is moved from X to Y. And the graph of voltmeter reading V is plotted against the slider position. Okay, it changes from X to Y. So what happens to the value of the voltmeter, value shown by voltmeter? Whether it remains constant throughout or it decreases from 4 to 2 or it increases from 2 to 4 or decreases from 4 to 0. Let us check this circuit here. So this slider can be either moved to this one, point X or point Y. So suppose this can, this is here at point X at the moment. So now it is a series circuit, potential divider simply, and the voltmeter will show 4 volt at this position when the slider is at X, because both the resistance is 10 ohm, this is 10 ohm and this is 10 ohm. Okay, so the current flows this way to the resistor P, resistor Q, and this. Since voltmeter has very high resistance, so it does not draw any current or negligible amount of current. So this will be, the path of the current will not be through the voltmeter. Current does not divide, it flows this way. So here the total resistance is 20 and the voltmeter will show whatever is the potential difference across both of them, that is 4 volt. But when we move the slider from X to Y, so we can consider, we can assume that as if it is connected to this point Y here. So this becomes a 4 volt and it is like Q here and P, because sliding contact is here, it means P and voltmeter are in series. And again, since no current flows through the voltmeter, so whatever is the potential difference, that will be across Q. There will be no potential difference across P because current does not flow through, because this is in series with V now. So current does not flow through this path. What is the path of the current? This. Due to high internal resistance of the voltmeter, no current flows through P. So now again the voltmeter will show 4 volt. But we can check it by applying the potential divider rule. These two are in series. We assume the resistance of voltmeter is RV and the resistance of P is RP. So what is the voltmeter reading? V will be equal to resistance of voltmeter over total resistance. Total resistance means RV plus RP into input. RV is very high, and because this voltmeter is resistance, and RP is very small. You can say RP is very, it's only 10 ohms, then RV. So we can ignore. So it means this is RV over RV, because this is 10 ohm, adding 10 ohm to voltmeter, it will be 20,000, 40,000. So that is too high. Adding 10 ohm will do nothing to the total resistance of the circuit. Into V in is 4. So this is cancelled. So what is the voltmeter reading shown by this? That is equal to input or EMF of the battery, that is 4 volt. It means whether whichever is the position of the slider, either X in between this or at Y, the voltmeter will continue showing 4 volt. So it means A will be the right answer. If the circuit were different means the supply is this is P, and this is Q, and this is the voltmeter which can be connected between voltmeter, and it can be varied from either it may be connected to X or it may be connected to Y. When it is connected to X, it will show 4 volt, and when it is connected to Y, it will show 2 volts, because this is 4 volt battery. They are identical resistances. Now current flows through this path. So potential difference across P will be 2 and Q will also be 2. So in this case, the second graph would be the answer. But since the diagram is different, so this voltmeter will continue showing 4 volt, whatever is the position of the slider. Excuse me. Next question. Same year, question number 37. This is, there are two resistances, 2 ohm and 4 ohm are connected in series. It's again a potential divider. Which graph shows how the potential V varies with distance between X and Y? So when charge flows, it uses up the energy. So here at this point, the charge has maximum energy. At which point charge has maximum energy? This point. And no energy is lost when charge flows through the wire, because wire has no resistance. So here the potential is maximum. When charge flows through 2 ohm resistance, the energy of the charge is used up and the potential decreases. So here this is smaller resistance and this is greater resistance. 4 ohm is greater. So it means charge will lose more energy when it goes from P to Y comparing to the movement of charge from X to P. So here the energy is maximum, means A cannot be the answer because this shows the minimum energy. B can also not be the answer. So at this point X, the energy is maximum. And when charge flows through this 2 ohm resistor, it loses the energy. And when charge flows through the wire in between the 2 ohm and 4 ohm resistor, no energy is lost here. So this means same energy. Whatever energy is here at this point, same energy will remain there till this point. Then again, there will be more rapid change in the energy of the charge because it is greater resistance. So it will be, this part will be steeper. So it means A and B are not the answer because they show the increase in energy. So C and D. So C is also not the answer because C shows greater loss in energy, rapid loss in energy or rapid loss in potential. But here the 2 ohm resistor is smaller resistance. So here the charge will lose energy, less energy compared to the energy it loses when it passes through 4 ohm resistor. So D will be the right answer. This one. Next question. 4 resistors of resistance R, 2R, 3R, and 4R connected to form a network. A battery of negligible internal resistance and a voltmeter are connected to the resistor network as shown. The voltmeter reading is 2 volt. What is the electromotive force of the battery, EMF of the battery? 2 volt, B 4 volt, C 6 volt, or D 10 volt. So let us check this. This is showing 2 volt. So here this is 2 volt. So what will be the potential difference across R? If 2R has potential difference, 2 volt, we know that when this part is in series. 3R, 2R, and R. 3R, 2R, and R. They are in series. It means they share the voltage. So, and R is, V is directly proportional to R because the current through 3R, 2R, and R will be the same. The current divides at this point and the same current will be flowing through these 3 resistors. So it means when I is same, V is directly proportional to R. So if 2 volt is for 2R, what will be the potential difference across R? That will be only 1 volt. It means the potential difference across 3R will be 3 volt. So total voltage or potential difference 3 volt plus 2 volt plus 1 volt. So that gives us 3 into 5 and 1 6 volt. So it means EMF of the cell is 6. This and 6 will be the potential difference across 4R also because this is in parallel to this combination. If you redraw the diagram, this will be the figure. This is 4R. And here we have 3 resistors in series. So this part network, this arrangement of 3 resistors in series in parallel to 4. This is 3R, this is 2R, and this is R. It means potential difference across 4R and these 3 resistors is same. So 6 volt will be for this also. We can have other way also. We can find out the current, and same current will be flowing through all of them, three resistance, and we can calculate the potential difference across other two resistances. So, but this one is easier method. Even then, I will show you the three resistors are in series. So the current will be the same. So I is equal to V over R. So we will take this one. So what is the current through this part? 2V over 2R. So 2V over 2R means I is equal to V over R. Okay. And V is equal to, if we compare these two, uh, I and R and 2R. If we compare R and 2R, what we will do? We will, let me erase this part. I is same. We will compare these two. Two R and R. Since I is same, 2R and R, we will compare these two. What is the potential difference across 2R? I1, we can say I1 is equal to I2. We can't say 1 and 2 because the current is same. So this is 2V over 2R, and this is, we don't know what is the potential difference across this one, how many volts. This is 2 volts, and wait, 2 volt, two and two cancelled, and I is equal to V over R. 2 and 2 cancelled, R and R cancelled. So what is the potential difference across one R? This is 1 volt, because 2 and 2 cancel, R and R cancel, so V is equal to 1 volt. In the same way, we can compare 2R and 3R as well. So answer is C, that is 6 volt. The current in a component is reduced uniformly from 100 milliampere to 20 milliampere over a period of 8 seconds. What is the charge that flows during this time? So here we have to take the average current, and when you calculate the average current, what is the average? It changes from 100 to 20. So 100 milliampere to 20. What is the average of the two currents? Divided by 2 means 60 milliampere. Means 60 into 10 raised to the power minus 3 ampere. So Q is equal to IT I 60 into 10 raised to the power minus 3. This is milli into 60 into 8. Sorry, time is 8. So 8 6 are 48 and this 0. And if we take this 10 to the power 3 as milli, coulomb. So answer is C. A battery with a constant internal resistance is connected to a resistor of resistance 250 ohm as shown. The current in the resistor is 40 milliampere during for a time of 60 seconds. During this time, 6 joule of energy is lost in the internal resistance. What are the energy supplied to the external resistance during the 60 seconds and the EMF of the battery? So let us first check what is the uh, this is the current. So we can easily calculate the energy supplied to the external resistance. 250 ohm is the external resistance. So energy is equal to power into time. I square R into T. So I square 40 milliampere means 0.04 square into R 250 and the time is 60 seconds. So this is 0.0016 into 250 into 60. When we solve this, we get 24. It means either C or D could be the answer. Now we have to check the energy supply to the battery is 24 joule. But we don't know what is the EMF of the battery. So EMF of the battery, we can apply this internal resistance R and external resistance capital R are in series. And same current flows through both of them. So it means EMF is equal to I R plus R. But we don't know the internal resistance. So what we will do to find out the internal resistance? We will apply the same formula here. That is E is equal to I square, internal resistance is small r, into T. What is the energy lost? 6 joule of energy is lost. So 6 is equal to 0.04 square into R into 60. So this and this, if we take this to the other side, R will be equal to 6 over 0.0016 into 60. So if we solve this, we get the value of internal resistance, and that internal resistance will be equal to, let me solve it. Mm, 1 divided by 0.0016, that gives me 625 and divided by 10. That gives me 62.5. So internal resistance is 62.5 ohm. So if I solve this here, point 04 250 plus 62.5. So when I solve, I get 12.5. That means D is the answer. Next question, question number 8. In the circuit shown, all the resistors are identical and all the emitters have negligible resistance. The reading on emitter A1 is 0.6 ampere. What are the readings on the other emitters? So this emitter shows which one? A1 shows 6 ampere. So it has two resistors in series with it. And all resistances are identical. It's mentioned the resistance are identical means they have the same resistance. Means two resistances and this shows 0.6. A2 will be the total resistance of A2 will be showing total of A1. A1 is already given plus, because this is parallel circuit, A3 and A4. I1, I3 and I4. So this has only one resistance in this in its path. So it means the value of current will be twice because potential difference is same. V is equal to IR. In parallel circuit, the potential difference is same. So I into R, it means this has only one R, current will be doubled. So it means this one will show 1.2 ampere. What about this one? This has three resistances. V is same. We can say V, we may call it V1. This is given and this one V4 is same. This has 2R, two resistances and the value is 0.6. V is equal to IR. I into R. I is 0.6 and R is 2R. What is I here? We don't know, but R is 3R. R. So 3R. So R and R cancelled. I will be equal to 2 into 0.6 is 1.2. 1.2 over 3 is 0.4. Means this one will show 0.4. This is 1.2 and this is 0.6. So when we add all of them, A1 0.6, A2, A3 1.2 plus 0.4, that gives us 0.6 plus 0.4 is 1, 2.2 ampere. This one will show 2.2. So let us see which one will be right according to our calculation. Remember all the answers, 0.6, 1.2 and 0.4 and A2 is 2.2. A2 is 2.2 and A3 as we calculated, because this is a single resistance in this path, so the current will be twice the current flowing through A1. So 1.2 and this is 0.4. So D is the right answer. This is the right answer. Question number 9. 100 ohm resistor conducts a current with the changing direction and magnitude as shown. So what is the mean power dissipated in the resistor? So power, what is the formula of power? And half of the cycle it's 2 ampere and the remaining of the cycle current reverses and its magnitude is -1. But power is I square into R. Power is, current is 100, resistance is 100 ohms. P is equal to I square. First cycle, 2 square into 100. 400. The negative cycle, P is equal to -1 square into 100. So that is 100. What is the average power? P average will be 400 plus 100 divided by 2. So what comes? 500 over 2 means 250 watt. So this is the answer. The diagram shows part of a current carrying circuit. The emitter has negligible resistance and the current which enters the junction is 5 ampere. And according to Kirchhoff's first rule, the current will be dividing into 3 parts. Total current entering the junction will be equal to total current leaving the junction. So what is the reading shown by the emitter, which is connected in series with 2 ohm resistor? So they all are in parallel, so it means the potential difference will be the same. So let us check what is the total R. When we find out the total R, 1 upon R1 plus 1 upon R2 plus 1 upon R3 and power -1, R total. So 1 upon 1 plus 1 upon 2 plus 1 upon 5 -1. So this is 1 plus 0.5 plus 0.2 means 1.7 and raised to the power -1. So what is our total? Our total will be 1 divided by 1.7. So that is 0.59. We can say this is almost, our total is 0.59 means 0.6 ohms. So what is V? V is equal to IR total current entering 5 into 0.6 means 3 volt. This is 3 volt. So what will be the value of I here? We know the potential difference across all three of them will be same. 3 volt for this, 3 volt for this, and 3 volt for this. So what is I? I is equal to V over R. V is 3 and R is 2, means 1.5. So C is the answer. A conductor consists of 3 wires connected in series. The wires are all made of the same metal but have different cross-sectional area. This is the current I in the conductor. So the current will be the same through all the conductors because they are in series with each other. The region X is the thickest wire with greatest diameter or greatest area of cross section. Then the area of cross section decreases to the second conductor and then to the third conductor. So here it means this part has the least resistance. There are different answers shown here. A, B, C, and D. So here C shows the potential difference remains same till the first conductor. Then it remains the same thing. That is not possible because the charge loses energy gradually when it passes through this. So it means there will be some uh, decrease in potential. So this C and D are not same. They are not right. The answer could be either A or B because there will be gradual change in the potential difference. So let us check because this X, this first resistor conductor is the thickest one. So R is smallest. Then R is slightly greater. This is thicker. It has less thickness. And this is the thinnest wire. So it means R is maximum here. Maximum R means maximum potential difference. It means the charge loses energy more rapidly. Means there will be steeper change in the potential difference or the change in uh, potential difference across the third part of the conductor, which is thinnest, which has maximum resistance. B is, it means not possible because in B it shows greater change when charge passes through the first part, then second, then third. So B is not the right answer. A, because this has the least resistance, this one. So it means V will be, the energy changes will be minimum. The charge loses energy slowly in this. So there'll be slow change in or less change in the potential difference when it moves from this to this point. Okay, the charge loses this much energy, then further like this becomes more steeper because this has more resistance than this one. The third part has the maximum, so it's steepest. It means A will be the right answer. So that's all for this lecture. Allah Hafiz.